Now we're going to integrate this complicated looking rational function. And we're going to try to use partial fraction decomposition to assist us. The bottom factors, obviously, so it looks like partial fractions might be a good way to go here. So you should be pretty familiar with this partial fraction decomposition by now. So this is x minus 6, x minus 1. That would decompose into a couple of fractions that will look like this. Let's multiply both sides by the common denominator. And now we're going to solve for a and b. We'll solve for a first by letting x equal 6. On the left, we'll have 21 minus 36. On the right, we'll have a times a negative 5. I'm sorry, a times a positive 5. That's 6 minus 1. So a would be a negative 3. We'll do it again, but this time we're going to let x be 1. So we'll be able to solve for b. On the left side, it's going to be 21 minus 6, which is 15. And 1 minus 6 on the right side would be b times a negative 5. So b also equals a negative 3. Interesting. So plug them back into our decomposition. We have negative 3 over x minus 6 plus a negative 3 over x minus 1. So that means that is the same as this original function. So instead of trying to integrate that original function, we're going to integrate it in this form. Those of you who have practiced integration over and over and over again can get this pretty quickly. They're both natural logs. Need a little bit of review. I'm going to integrate across the sum. In other words, integrate each of these separately. Factor out the constants. You don't have to show this process. You can do it without it. But now, in both fractions, the derivative of the bottom is 1, which is what's up on top. So these are natural logs. Negative 3 times the natural log of the absolute value of x minus 6 plus negative 3 times the natural log of the absolute value of x minus 1 plus c. But I'm not going to write the plus c yet because I can see there's some simplification that can be done. Factor out negative 3. The natural log plus the natural log would be the natural log of the products. And then you could also just multiply that out. And you can also raise that to the negative third if you want to do that, but we won't. Now, seems like a pretty simple answer. That tells me that there may have been a different way to do this problem. And if you would have noticed this in the beginning, it would have saved you a lot of time. But bringing it down, the process did work. But let's look for the easier way. This will not take long. If you think of the derivative of the bottom, which is 2x minus 7, if you factor out negative 3 from the top, you get 2x minus 7. So now you immediately have u prime over u, which means this is negative 3 times the natural log of the bottom, which is what we got with partial fractions. So you can see it worked with or without partial fractions. That's good news, because the next problem we do will probably require partial fractions. Stay tuned.